then it begs the question of, if I work here, how do I come here to work? How do people go all the way here to work if the MRT station is here? From my understanding of this place, because I live in Punggol, so it's a place close to my heart, this is probably a 10 to 15, possibly 20-minute walk from the MRT station. So because it's a place that is, the brief states that it's a place for millennials, freelancers, and small startups, therefore, I think that the logical way by which people will come here to work will be using bicycles, they will using personal mobility devices, scooters, hoverboards or whatever not, okay, to basically arrive at this place. Or people will also probably be cycling or jogging to work, and probably would enjoy having a shower facility if they jog or cycle to work before they actually begin work in a place like this, okay? So it's actually some distance, and I think these are all included in your brief for the design competition. Okay, so it reminds me of a project which we won via design competition. It's a public housing project. We did it for HDB. It's located in Tampines. In Tampines now, they actually cleared out an open green area to basically plan a new neighborhood in the northern end of Tampines, which they're calling Tampines North. And one of the things that the housing board is doing is they basically designed for a linear park, which they've called the Boulevard Park, that will basically stretch to another park which is connected to an existing park called Sun Plaza Park. So if is anybody here living in Tampines or familiar with the area? Okay. So the site is actually some distance from the MRT station in the town center. So it's one of those places that if I was going to live here, it's probably the kind of place that I will use a bicycle or use a PMD to get to and from the MRT station in the town center. And that's why I thought it's probably appropriate to think about to use this project to illustrate how certain ways of getting to and from a site would be useful. So this is the site. This is from the URA master plan. This is the site. This is the linear park that they have planned. This is another park that they are planning. This is Sun Plaza Park in Tampines. Here you see basically Tampines Town Center. So it's probably a 15-20 minute walk as well, or if you're using a bicycle. So we thought a lot about how does one go to and from the site when we were designing it during the design competition. What is the experience of going from the town center and, let's say, using one of those bike sharing platforms to basically go from the town center to go home. So when we were designing the site, we thought about it in a few ways. First, of course, we enjoyed the frontage. This is our site. We enjoyed the frontage along the Boulevard Park itself. And so what we wanted to do was we wanted to create our own secondary boulevard park within our site. We also found out that the housing board was planning to build a common green across the street. So we then decided to build a green connector that basically bisected the site to create an intersection. But we did not want this path. We did not want this path to be just a path or a small narrow walkway. We wanted it to be a space that is wide enough such that you can actually define the space with buildings. And then what we wanted to do, okay, there's a cheesy term from the housing board. They called it a community bud. They're actually essentially activity nodes or areas by which, as one uses the Boulevard Park, you can introduce certain types of activities. So HDB required us to do 2. We proposed 4. And these are basically, the idea behind these areas was to basically use the edge between our site and the Boulevard Park, where we can introduce activities to basically greet people and in a way blur the line between what is housing and what is park. And so our idea was to basically wrap a series of residential blocks around each area to basically define the space. And then from there, each of these courtyards will basically have portals that will basically allow and welcome people into the secondary Boulevard Park, into the second row of blocks directly behind it. So then the other thing that we did was when we actually did it up in 3D, we wanted the blocks to step down from the maximum height of 14 stories, terracing down to 11, and then subsequently to 5 stories, so that each area basically feels like it's enclosing a defined courtyard. So sense of arrival. When we go back to your Punggol site, think about sense of arrival. Think about if I was going to jog here, if I was going to cycle here, if I was going to take my PMD to go to this place, how do I get to this place, and how will it feel to get to and from this place? I think another specific thing that is specific to the site that maybe I'd like to plant in your minds when you guys are working on the project is to think about the relationship of the site to the water, because you're in Coney Island, your site is next to the water. So how do people go to and from the site into the waterfront? If I work there, of course, it's easy to design a building that opens up to the water, but it becomes a question of, do you want to design your building such that it invites people, not just the people who are working there, close to the water? And what does that do to the site? Okay, so going back to this project, this is how we basically define the buildings. We basically define them as a series of U-shaped clusters of blocks facing the Boulevard Park. And the idea is that you basically have a courtyard that basically is married together with the Boulevard Park, and each one with a portal to go to a courtyard in the middle of the site. And thus, when you basically break it down, each cluster basically is a block that basically rises up from a low-rise building to a mid-rise building with roof gardens up to its highest point, and then with a courtyard in the middle, welcoming people. So the courtyard is designed to welcome people. It's got activities, it's got spaces. Then here it's where people can gather, do their morning Tai Chi, for the elderly to do their line dancing at night. And then from there, they basically walk into the site. And then once they walk into the site, we designed for a portal. And then we thought about what happens when you walk through that portal. So when you walk through that portal, we designed it with a double volume living room space, where you're greeted with a CLR is a community living room. So it's basically a jazzed up void deck, with seats, finishing, places where people like yourselves can do your homework, meet your friends, wait for your friends within the block while you're waiting for them. You can message them while having a comfortable place to walk. And then from there, you can actually take a landscape staircase up to the landscape deck of the building itself. So that's designing for place, thinking about how one place, one site connects to each other, how one arrives at the site, how, if there are assets in the site itself, how does one maximize them? And then I'll go into the third part, which is the part I've been asked to talk to you about, which is designing for productivity and going through the different methods of construction that has evolved over the past several years. So of course, we're familiar, the most traditional way is to do projects cast in situ. And then, of course, in Singapore, we have precast technology, which is being used in HDB. And then recently, now we've been using PVC, but before that, we actually were doing PVC, and now we're doing PPVC. And I'd also like to touch on MET, which is a technology called mass engineered timber. Okay. So I'd like to go through a couple of projects, and I think as I go through those projects, I will also be touching on some of the items that I spoke about when we talked about designing for people and designing for place. Okay, so our journey, PNT, when we started to work on PPVC projects, it started when we started to work on the student housing residential halls for NTU. These are the North Hill residential halls. They're basically 6 blocks of 13-story buildings, about 1,600 over housing units for students. Okay, and this project gained a lot of mileage because it was one of the first projects to use PPVC technology. This one used a steel system. It's a steel system, steel PPVC project. Okay, so this is what it looks like in 3D. Okay, there are basically 6 towers sitting on a podium with landscape deck. Okay, 3 out of the 6 towers actually adopt a cruciform shaped plan. Okay. And we actually used, after we did the whole massing in BIM, here we were still using Revit. Today our office is actually using ArchiCAD. We actually ran the entire site plan through using computational fluid dynamics, CFD, to basically test out how the site responds to wind. Okay. So there are very, very many ways to interpret data. Of course, sometimes when this process is normally done together with a specialist who basically runs through the data. You don't just run the simulation, you also need to extract out interpretations from it. And so of course, from here, the normal instinct would be red is bad, blue is good. But actually that's not true. The way it's interpreted is that what we are watching out, for example, in this diagram, is to basically look at pressure differentials. So for example, if the pressure here and in here is big, it means that the wind is flowing through. Because it means that that building is basically absorbing and enjoying large amounts of wind because you're basically seeing large amounts of pressure differentials in the way the wind responds to the building. So if you go through the, assessment of green mark to score points using CFD, there are lots of criteria, both in the site scale as well as the building scale, down to the unit scale of how wind actually passes through. And you can actually use the BIM software, regardless of what platform you use, whether it's Revit, ArchiCAD, or whatever software, to basically, there are plugins available to basically simulate how it behaves in terms of building orientation, how it behaves in terms of how it responds to wind, and so forth. Okay. Okay. So when we were designing NTU, we basically adopted a hybrid system, in that the podium levels and the core, the tower core itself, which is in green, the lift core and the staircase, were done using traditional methods of construction. And then it's actually the student housing modules, units themselves, that we used PPVC. As I mentioned, this is what it looks like in 3D. So the area itself, the tower, the core where you have the lifts and the staircases, these are actually all done using conventional construction, as well as the podium on which the tower sits on, whereas the student housing units themselves are the ones that use PPVC modules. Okay, so I just want to go through some of the principles of PPVC for you guys. Okay, so the key driver of this is to basically extract savings in terms of labor, because most of the labor is done in a controlled environment in a factory, and you basically lessen the amount of labor that is needed on site. Okay. Of course, as the industrial process basically evolves, the industrial process will basically involve more automated fabrication systems, which will basically improve the overall quality and the safety of the production. The next thing is, of course, we can actually, because you're building these modules in a controlled environment, you're building them in a factory, you're not building them under the sun, under the rain, like what we're having outside. So therefore, you can achieve better outcomes in terms of consistency and quality. Okay, you can basically coordinate a lot of things off-site a lot better. All in all, much higher levels of quality control. And of course, you get a lot of safety improvements because you have less manpower on site, less wet pour, less activities, because you're basically transporting many of the construction activities that would otherwise happen on site, off-site. Okay, and of course, for this particular project, we saw a lot of gains in terms of productivity. It's about 30 to 50%. This was actually the sales talk. Actually, it's a little less than that, but it's still significant gains. Our experience using more recent systems, basically we count not in terms of time or months saved in construction, but man hours per square meter in terms of productivity. Okay. But the idea is to basically also shorten the floor cycle of construction from 21 to 21 days traditional, and then we can actually improve it to 4 days when we use PPVC construction. But this number actually swells up in actual practice because you have to spend a lot of time managing the logistics. Okay. Then of course, I want to go through some of the considerations that we probably need to go through when we want to do DfMA. First is the idea of modularity in design. So of course, the idea is to have repetitive designs that you can actually replicate over and over again. So we have to think of construction as a much less the traditional way of that you're building something on site, and you have to think of it more as a manufacturing process, almost as a mass production process. Okay. So the other thing that needs to be considered is the size of the module, because we have to consider that this module will be built in a factory off-site and it will have to be transported. So how does it go from the factory to the site? You have to control the size. Okay. And of course, so that you can achieve economies of scale, you should have enough repetition of the modules so that the system itself is definitely more expensive compared to traditional systems. So therefore, the higher number of repetition, the more economies of scale that you work. Okay. Okay. And of course, you also have to think about site considerations. So for us, a larger site area is important because just as you hoist these things into place, you also need a holding area. You need an area where you can keep these things at place so that you can transport them seamlessly on site. So areas that have lots of vacant land nearby are very, very ideal to use this type of system, which is why perhaps Coney Island is a suitable location to use such a system. Okay. Of course, areas that have low traffic are also important because you have to think about transporting such a large object through traffic, as well as The other thing is, of course, the capacity of the tower cranes. So for this particular project, we basically used tower cranes with a 24-ton tip load, okay, based on a 24-meter radius for the crane to be able to grab this very, very heavy object and basically hoist it into place. So for NTU, the module, you said I showed you earlier that each module is about 4 over-meters. It was broken down into 2 modules. Each 4-meter module is broken down to 2 modules of about 2 over-meters by 3.14 meters in height, about 10.35 meters in length. This is for NTU. Later on, I'll go through with you guys how it's being practiced now, because the allowable is slightly bigger than this. Okay. So what we did was basically, as mentioned, the bigger components, the ones in purple here, the toilets, the laundry areas, the staircase, the lift, they were done using conventional construction, and we used PPVC construction for the units. Okay. So we basically worked out a few different types, whether they were basically each housing unit basically has a slightly different type based on how much rent you pay, whether you want to have your own room or whether you're sharing it with somebody else. Okay. So we also did apartments also for the faculty members who are basically living in these hostels. Okay, and this is basically what it looks like when you basically assemble one set of units together. So basically we think about how the whole thing gets assembled together, from the key components, from the floor to the walls to the ceiling to the slab above, to basically your walls, your windows, and even the window treatment. In this case, because we had to cater for students drying their own clothes inside their own units, we basically designed for clothes drying racks with perforated screens so that as you hang your laundry, your neighbor won't see what color of underwear you wear. Okay. Okay. So basically they're installed in that manner. Okay. Okay. So this is what the mock-up looked like on site. Okay. So we're able to actually use the mock-up and basically inspect it for defects and whatnot before we hoist it into place. And this is what it looks like on site when we were reviewing it. And this is the mock-up as it was being hoisted into place. Okay, so this is the finished building.